Okay, now I want to say one more word about notation, which is that this notation is an extreme nuisance here, and it's really sort of too large for us to deal with. And so mathematicians have a shorthand for it. Unfortunately, when you actually do a computation, you're going to end up with this collection of stuff anyway. But I want to just show you the summation notation in order to compress it a little bit. So the idea of summation notation is the following. So this thing tends, the idea is the following. I'll illustrate it with an example first. So, well, the general notation is the sum of AI, I equals 1 to n, is A1 plus A2 plus ... plus AN. So this is the abbreviation. And this is a capital sigma. And so this quantity here, for instance, is 1 over n cubed times the sum I squared, I equals 1 to n. All right, so that's what this thing is equal to. And what we just showed is that that tends to 1/3 as n goes to infinity. All right, so this is the way the summation notation is used. There's a formula for each of these coefficients, each of these entries here, or summands, and then this is just an abbreviation for what the sum is. And this is the reason why I stuck in that 1 squared at the beginning, so that you could see that the pattern worked all the way down to I equals 1. It isn't an exception to the rule. It's the same as all of the others. Now over here, in this board, we also had one of these extremely long sums. And this one can be written in the following way, and I hope you agree, this is rather hard to scan. But the one way of writing it is, it's the sum from I equals 1 to n of, now I have to write down the formula for the general term, which is b over n times I b over n squared. So that's a way of abbreviating this massive formula into one which is just a lot shorter. And now the manipulation that I performed with it, which is to factor out this b over n cubed, is something that I'm perfectly well allowed to do also over here. This is the distributive law. This, if I factor out b cubed over n cubed, I'm left with the sum I equals 1 to n of I squared. All right? So these notations make it a little bit more compact, what we're dealing with. The conceptual phenomenon is still the same, and the mess is really still just hiding under the rug. But the notation is at least fits with a few fewer symbols anyway.